Hi, everyone. Welcome to a conveyor meetup. So today we have Philip Hayes, who will be presenting to us on how to migrate applications to Kubernetes. Before I hand it over to him, just want to go over a few housekeeping items. So first of all, if you have any questions, feel free to put it in the comment section. I'll likely wait for Philip to get through his presentation before I ask him any of those questions. Second of all, I'll put the link to the slides within the video description after the presentation is over. And then lastly, if you're new to the community or you've been trying to use our tools and for some reason you're getting stuck on one part of the process, feel free to ask these questions in the Conveyor Slack channel. I'll put the link to that channel in the comments. But you can also ask us questions that are a little bit more broad and a little bit more higher level about approaches to migrating Kubernetes in general. We'll get someone there to answer your questions for that. So with that, Philip, I'll hand it over to you.
Thanks, Jonathan. So hopefully everyone can see my screen okay. Let me just skip on to the agenda. So this is what we're going to go through. So this presentation really is focused on EAP workloads, and we're going to look at the benefits of moving those workloads to Kubernetes. So we'll start off with just having a look at the current state of EAP and where those workloads live, some of the benefits of moving them to Kubernetes, and we'll go through the steps, generally what would be involved in doing that move. We're going to go through a kind of a step-by-step process then with a sort of a kitchen sink EAP application, build an image for OpenShift using the S2I builder, and then we're going to run that then on OpenShift as well. So what's the current state of EAP workloads? Well, the reality is the majority of them are still not running in the cloud. The vast majority are running on VMs, and we're going to see and expect a very large demand to move, shift or modernize these applications over the next couple of years, moving them to the cloud. So one of the areas where we feel that that is the one of the best places to run these workloads is on Kubernetes. And the reason for that really is, that there's a lot of benefits to moving EAP workloads to Kubernetes. Significantly, we would expect reduced operational costs, and that's going to come out of a number of different areas. I mean, one of the areas is improved resource usage. So, for example, as part of this demonstration, we're going to use the OpenShift EAP S2I builder, which allows us to do things like, introduce Galleon layers or exclude, layers as well, more to the point, to reduce the footprint of the EAP images. We can also take advantage of things like integrated monitoring and metrics that come with Kubernetes platforms, and the vastly improved developer experience as well. And, again, from the OpenShift perspective, we'll see the developer UI, which gives a really nice interface for developers to be able to work with their workloads on the platform. Kubernetes itself replaces core EAP functionality. So things like clustering and so on, that's all managed really out of the box with Kubernetes platforms. And from Red Hat as well, we would also expect additional benefits from the Red Hat Runtimes bundle as well. So being able to benefit from things like data grid and SSO for security and AMQ broker for messaging. So really sort of starting to bring in more sort of cloud native development technologies into the platform. So if we look at the steps to migrate, so this is typically what we would need to go through to migrate an EAP application to Kubernetes. So first thing we're going to do is we're going to use Tackle to analyze the application for cloud readiness. So is it are there any reasons or any issues with this code that we would need to address before this would run well in a Kubernetes environment? We then make those code changes as well, and Tackle will give us recommendations, and it will also give us some guidance on how to make those code changes. We will also, in the case of EAP, need to identify any dependencies. So, for example, the application that we're going to migrate today uses an external MySQL database. So there is a MySQL driver deployed, there's a JBoss connection, so on set up. So we'll look at how we would do that in a sort of a Kubernetes world. To do that, we're going to update the repo. Well, I'm going to show how the repo has been updated. I've already done those changes. So the repo would be updated with those configurations. And we're then going to use Helm charts to create the build configs and trigger the, to actually create the EAP image that we're going to deploy. Because we're using an external database, we're also going to create some runtime configuration. So, database connection information and so on. And then we're going to use the EAP operator to deploy the image to Kubernetes. So just to go through a couple of steps. First thing we're going to do, we'll just go on to a quick demo of doing the analysis of the application. And once that's done, I'm actually going to trigger the deploy using the Helm chart. And then I'm going to kind of skip ahead a little bit and do that. And then I'm going to backtrack, talk about what's going on there. The reason I'm going to trigger that is because it takes about 6 minutes, 6 to 8 minutes and so on to do the build. I don't want to be sitting here looking at logs for a few minutes. So we'll kick that off and we'll come back and discuss what's happening. So first thing, let's do our analysis of our application. We're going to use Tackle. As I said, I have this sample. It's one of the quick starts from the EAP quick starts. It's the kitchen sink demo, which is a simple sort of database interface to be able to kind of create, manage contacts and so on. I've made some changes to that in order to use an external MySQL database, just to kind of make this presentation a little bit more real world. So let's first off do some analysis of this application. Let's make sure that there's no blockers to prevent this from running in Kubernetes. So let's create a project in Tackle. Let's call it kitchen sink. Okay, and we're going to upload our artifact. So here's our WAR file. Okay, and I'm really only interested in containerization. I know this is already an EAP 7 app. Now, this could be another Java Enterprise application app, and we would then do some analysis here to ensure that to figure out what we need in order to migrate it to EAP 7. It could be an older version of EAP as well. But in this case, I'm just going to check it for cloud readiness. So can it be containerized? So let's go through. I'm just going to select the package. That's straightforward enough. I don't have any custom rules. I'm going with pretty much the out of the box configuration here. Same with labels. And this should just give us a summary then. So you can see here again, we've just got the cloud readiness target. We're not making any of the changes and going with all the defaults here. So it's pretty straightforward. And as everyone knows, this could be run through a CLI, or it could be built into a CI/CD process as well. If some code changes are required, that could be built into a CI/CD process to give you a cloud readiness. How many story points are required in order to make this cloud ready as you're building it. So let's go through and we'll kick off this job. Okay, so let's give that a go. Let's give it. It shouldn't take too long to run. Time for drinking my coffee. So there we go. So that ran, and it took a couple of seconds. Let's have a look at the report then. So as I expected, the zero story points required in order to make this cloud ready. So we can see under here, there's no cloud mandatory. There's a few little information things here I don't need to worry about. But I can be confident now, after running this, analyzing my application, that this WAR file will, if I build it into an EAP image, it will run well in a cloud environment. So that gives me great confidence to move on. So what I'm going to do now is, as I said, I'm going to deploy the Helm chart just to kick off the build, and then we'll come back and we'll look at what's going on there. So all of the code that I'm going to be showing here, it's all in this repo. I'll put a link to this in the chat actually at the end. I don't think I included it in the presentation. So this is the configuration for the Helm chart. This is the YAML that I'm going to deploy. Okay, and really the key thing here is there's my repo. there's the branch, there's the directory, and I'm using a pull secret as well, just to pull down from that. To pull these images down here as well. So we just copy this anyway, and we'll kick that off. So, okay. And let's go back to here. I'm going to go over to the developer view because this is really where the developers live when they're using OpenShift. And I'm going to add, and I'm going to use the EAP Helm chart. So let's select that, EAP 7.4. If I install that, and I'm going to just paste the YAML here then. Okay, let me just go back to the form view, and we'll very quickly just see one of the key things here is I'm disabling the deployment option. I'm just using Helm to do the install, to do the build. I'm going to use the operator to actually do the deploy, and create the route, and those kind of things. But this, this build, it's just pointing to, my GitHub repo, my branch. It's got my directory there, and so on, and the pull secret. So there's nothing too complicated there. And then let me hit on install, and we'll see when I go over to builds that it's actually created 2 build configs. We've kicked off one of them. We've kicked off this build artifacts build config. We'll see here that's running. And as I said, that's going to take, I think, about 5 or 6 minutes or so to run. So while that's going on, let's go back to our presentation, and we'll look at what's happening now, what that build is doing. So we're using the OpenShift source to image builder, right, which is going to create an image containing the EAP runtime plus our application to be deployed. So in order to do that, it will check out the Git repo. It'll perform a Maven build on the source code, so to create the WAR file. It'll then copy the artifact then to EAP home deployment, standalone deployments in the image. It'll copy over any configurations as well if we've got a custom standalone XML file. It'll also inject artifacts as well. So, for example, if we needed to add any additional drivers or modules and so on, it will inject these as well. And I'll show you where those are in the repo in a second. What it will do then is it will produce an EAP plus an app image, and then it'll trigger another build which will actually create the runtime image. And I'll show that in a diagram on the next page. But just before I move on to that, let's just have a look at the artifacts that we're going to be copying over. So this is the repo that I've just told it to build the application from. So this is my version of the EAP Quick Start Kitchen Sink demo. And as I said, I updated this to use MySQL rather than the H2 database. So in order to include the modules and the drivers and so on required for MySQL, I've added them here. So you can see here, I've added a module which has got the configuration, telling it to use this, to add this jar file, okay? And I've also added this extensions folder as well, which basically the S2I process will pick up this extension, it'll run this install shell file, and it will basically run this configuration to configure the drivers and add them to the EAP deployment. So so without making any code changes, I'm not making any code changes to my actual EAP application. I'm just adding some configuration here for the required drivers that are needed for MySQL. So the only other thing, so once this is built, the only other thing I'll need to add in then at runtime then is the connection information to my MySQL database. So this is the process. So as you can see, there's two different builder images. We've got the first one, which will basically take the and that's the first. I've missed one of those slides. Let me just find you the slide for that. There's one of the slides because there's a separate process here. So basically, what happens is that it's a two-step process. So there's an initial build which builds the does the Maven build, creates the artifact, but that image is very large. It includes all the build tools, all the Maven tools, and everything else. So you'll end up with an image which is about sort of 800 to 900 megabytes in size. Okay. So what happens then is there's another build that triggers off, which just takes this build artifact and adds that to an EAP runtime image, which is much smaller, and the resulting S2I runtime build, as it's called, is vastly reduced. We're looking at about 370 meg as opposed to close on 900. So we're reducing the image size by getting rid of all of these sort of build tools and so on that aren't needed. We're also using things like Galleon layers as well to basically reduce the amount of EAP runtime that's required as well to run this application. So as I said previously, we will get a vastly reduced resource usage for these images. This is an example of some of the layers which are available with Galleon. So, for example, if you're writing a simple sort of data, web app that needs to access a database, you would just include this layer. You wouldn't need these layers. You wouldn't need observability or SSO, for example. You will just get the required libraries that you need in order to run the application. So, so this is the second slide. Yeah. So basically, as you'll see here, we combine the first builder image with the resulting layers reduced down, and we get down to 274. So you can see that in the previous slide, if we look back, this is without Galleon. We've ended up with an app runtime of about 370 meg, the image size. With Galleon, you can see we're reducing that again down to about 270. So it's all about managing resources, creating higher density on our nodes and so on, which is obviously a big benefit. So when we come to deploy this application, we're going to deploy it with the EAP operator. That's the recommended way to do that. Currently, there are some advantages to that. So a couple of the main advantages really is that you can manage multiple EAP Java applications across the cluster. So the administrator will deploy the operator, and then it's up to the developer then to use that operator then to deploy their EAP applications. The operator manages safe transaction recovery. So because it uses a stateful set, it will only shut that when you go to scale down your stateful set, it will only do so once the transactions and so on have been completed. It also supports EJB remoting because, again, through the use of stateful sets, we'll have these sort of static host names within the cluster, so we can do things like EJB remoting and so on. So we'll go through that in a second. We'll run that through. So let's go back to the demo. Let's see how our applications are running. Oh, it's logged me out here. Let me just go back in. Okay. So there's my log. That's a good start. Let's go back here. Let's see. Well, that hasn't happened before. Isn't that? That's always the demo gods know, isn't it? Service unavailable from registry.redhat.io. I wonder, is it unavailable? That's that's not what I expected. Now let me just try and build that again. Let's click on the logs then, let's just say. Because I've put everything in. I mean, there isn't really much to deploy at this point. And I tried this out yesterday afternoon, and it all ran perfectly. So that's just typical, isn't it? Okay, let's just give it a second. And that's frustrating because, as I said, it takes about 5 or 6 minutes for this to start up. So let's get it started off anyway, and then we'll see if there's any questions that we can discuss just while this is building.
So we don't have any. So just to let you know, Philip, at the moment, we don't have any questions.
Okay. Can't pull the image. Interesting. Got my pull secret there. That should be fine. Yeah, so I'm not sure why that can't pull the image. It's trying to pull an image from registries.red.io. Let me just, I presume it's, yeah, I mean, it's okay to me. Okay, so I'm not sure why that's not running. I'm gonna kill this again. Let's just kill the Helm chart. We'll just create it again, but that's not. I haven't seen that before. As I said, I tried this yesterday and it was fine. So let me just try again. Go back to my code. There's my Helm configuration. Right, so let's have a look at the build then again. Still looks like it's got to the same place. You're looking at this is the repo that I'm running. Create a project. I haven't created a database yet because I don't need that yet. I created my secret, which is called my pull secret. And then I'm installing the Helm chart. So that should kick off the build. That's what I did yesterday. But it doesn't look like it's able to pull an image.
Somebody said maybe it's a outage on redhat.com.
Is there something being reported on that?
Maybe. Let's see.
Well, that would be a certain cause, all right. Okay. Look. Registry.redhat.io is down. So that's not going to work until that's down. Well, that's frustrating now. There's nothing I can do about that to resolve that. So, so the build isn't going to work, and that's a shame. So let me go through anyway. I can go through the configuration here and let's sort of see what's happening. Because it's really pretty straightforward. Like once we get this all running, like this is the configuration for Helm. So again, you can see here, this is where it's pulling the build of images from. It needs to pull these from registry.red.io. Okay. As I said previously, I've disabled the deploy option. I'm setting so there's no replicas and so on being deployed. So all this will do is check out the code from our repo. It'll use this branch. It'll then use this directory, and it will then perform the build then. So it'll first of all, it will create the artifact with this build image. So that will do the Maven build. It will copy over all the modules. It will do everything that's needed in order to make this a running EAP image with our build application. And then it will trigger a second build then, which will use the runtime image, which again, as I said, is a much more reduced image size, and copy over just what's needed in order to run our EAP application with this reduced runtime. So once that's done, then it will deploy that to an image stream. So it'll be within the namespace where we've built it, which in our case is EAP webinar. Still can't pull that image, you can see. And then once that's done, then all I need to do is, if we go back to the repo again, all I need to do then is deploy our database. So I'm just using simple MySQL database here, and then I can create a config map with all of the the connection information for that database. So that config map is pretty straightforward. That's just the data there. So this is the configuration that I use to create MySQL. Now, in a production environment, I wouldn't be using a config map for this. I would also use a secret as well for any credentials and so on. But for a demo, I'm just using a config map. So once that's defined, then it's a case of, with the operator, deploying an instance of a Wildfly server, which is the custom resource for the EAP operator. I'm going to tell it to use this image. This is the image that was built by our build config. So again, the Helm chart is going to kick off those builds. The result will be an image stream EAP7.4. I'm going to pull the latest image from that, and I'm going to deploy a single replica of it. And I'm going to use this config map, which is my SQL database configuration. So let me just go ahead, just while I'm here, I'm just going to go through and install the EAP operator, because what's quite nice there is once I deploy that. So you can think I've got my, I'm the administrator at the moment. I'm deploying an operator. Let me just deploy that, and I'm going to make it available to all namespaces. So, and what's nice about this, obviously, is this is something that the system administrators will do, and then it's up to developers then, or individual teams, to use this operator to deploy their applications. So once this is complete, you'll see this will appear in the dev UI for my developer as an operator-backed option for when I want to come and deploy applications. Let's just check the status of the registry again. Still looks like it's got a major outage. Thank you, demo gods. That was very timely. So this should be finished now in a second. Although that might be pulling an image as well. It probably is. Yeah, that's probably pulling images as well, which is OpenShift operators. Okay, is it running? Yeah, there you go. So that can't deploy as well yet. So there's going to be problems doing any part of this demo then, unfortunately. So apologies to everybody on the call for that. It's pretty bad timing for the Red Hat registry to be down. So I'm kind of snookered about that. But so anyway, so once the operator is deployed, as the developer, then all I need to do is just create this Wildfly instance. That will then use the image that we've built, and it will then deploy that then as an EAP application. And what it does along with that is it creates the routes, it creates the services, it creates the stateful set. So it really manages that whole, everything that's needed to deploy the image is all done then through the operator. Yeah, but as I said, unfortunately, we can't show it. So yeah, so that's it. So look, is there any questions I can talk to, because that I was supposed to be another few minutes running this demo. So
thank you, Philip. So anyone, if you have any questions, feel free to put it in the comment section, and we can get Philip answering some of them.
Still outage, yeah. Yeah. So no questions, all quiet.
Yeah, so far, no questions. So everyone, I did put a link in to the survey for this meetup. So please fill that out. That helps Philip and me know what we're doing well, where we can improve. And yeah, so Philip, I think that'll be it for today. I think you did an awesome job on presenting and giving this demo, and I'm pretty sure that's why we don't have any questions today.
Yeah, well, thanks. Apologies for everyone for not being able to actually do the demo. That would have been nice, but I think it would be nice maybe to get a recording of this up on YouTube or something, and we can kind of maybe link to that, maybe send it out. Like the thing to do, because it is pretty cool when you see it all going. And the nice thing is, again, it's once these little changes are in place, like copying over the modules and the drivers and so on, there is no code changes required to the code, and you've got these pretty flexible tools to manage the whole migration and get them up and running on Kubernetes. So
yeah, we can certainly do that. We'll link to the recording within the description of this YouTube video. And also, Philip, I did just have some questions come through. So the first one is, how would one detect JBoss running in containers?
How would one detect JBoss running? So from a code perspective, to figure out whether or not you're running in a container or not, would it be? It's a good question. It may be, just off the top of my head, you could do something simple enough, like look at the environment variables, because you get a ton of environment variables injected into the container by Kubernetes, so you could use something like that. There's probably, if you wanted to kind of be even more thorough than that, you could probably look at making sort of API calls as well, because you should be able to make API calls back to Kubernetes from your container as well. So I would say, if I was looking at it, I would probably look at doing it through the environment variable method initially. That would tell you whether you should be able to figure out from the environment variables, I would imagine,
Okay. And then the next question is, given this unexpected outage, how can we ensure against global outages of SaaS registries, such as we're experiencing right now? Pull images.
Brian's kind of answered it there as well. Yeah. That there are ways, obviously, to mirror the images. There's very good tools around being able to almost run your entire Kubernetes cluster in a disconnected mode with your own image repositories. There's tools available to mirror all your images and put them into your own repositories. But Quay is a good option there. You can do that. One of the things we've done on a lot of consultancy engagements as well is we will preload nodes with images. So it reduces the need to pull down these public images as well. So if you're using certain images, you can use things to actually populate these images on the nodes already, so they're already pulled down. But I would say having an alternate image repository is probably the more standard way of doing it, though. So
okay, yeah. So Ryan Nix, I think, responding to that question as well. with Quay repository mirroring, lets you mirror images from external container registries.
Yep.
All right, everyone. So I think those are all the questions, Philip. So thank you so much again, and we'll get that recording up and link to this in the description. I think it was just the bad luck on our end.
Okay, there's another question there. Running VM-based apps, I appreciate. Want to migrate? Okay, yeah. I mean, so that's really where Tackle comes in. You know, when you're looking at migrating EAP 6 apps to the cloud, like chances are, to be honest, they will probably run. You know, unless there's some maybe kind of RMI calls, those kind of things in place. But using Tackle, you know, that will tell you very quickly what's involved to migrate your 6.4 apps to 7.3. You know, what changes are required. So that will be the starting point for all migrations, to go through Tackle, do that analysis. That will tell you what the what story points are, what the changes are. It'll give you recommendations. Make those changes, and then you can migrate that up then to 7.3. I mean, there's been a lot of talk, I think, around things like Picketbox and that kind of stuff, and Aditron replacing that. You know, Picketbox is still there. It's sort of depreciated, but you know that those libraries are still in place. I think they'll be gone in EAP 8, but as long as you're on 7.x, they should still work. So yeah, so I would rely on Tackle to do the analysis and tell you what the work is involved. You know.
Anyone else have any questions? Yep. So which was the tool they used? Was it Tackle or MTA, yeah. Philip?
Well, I used MTA, yeah.
Okay, so yeah. So, well, do you have a link to that within your slides, Philip? They're asking for the link to that.
Let me put a link to it. Here's the link. I'll put it in the chat, and people can. So can I add a comment? How can I? Where can I?
You should be able to. It should be on your right side. There should be a tab that says comments.
Yeah, I'm on that, and I don't have a box to put anything in though.
Okay.
Huh. All right. Well, there's the URL there. Anyway, you can see it on my screen.
There you go.
Yeah. Let me just check the status one more time. Still a major outage. Well, there you go. Fix has been implemented. Let me just check. Let's just see if anything's happened here with these builds, because they may have still been trying to run in the background here. So yeah. Sounds. Let's just rebuild it and just see. Just see, do we get past the stage? Yeah, it looks like it's still stuck. All right, look, all right. We'll leave it at that. Thanks, Jonathan.
Yeah, of course, Philip. Bye, everyone. Till next time.
Right. Thanks, Ed. Bye.